Hi guys, just to prepare before we come in and we start talking about base and place value, I do want to take just a little bit of time to review sort of the knowledge that should be there somewhere in our minds, even if it's buried really deep, since we might have not thought about it since our own elementary school experience, just so that you're prepared and kind of transitioned into this mode for learning Monday when we see each other. Hey, so just to point out first, people often use the word base and place value interchangeably. That's not necessarily true. As we saw in some of the number systems we worked with last week, it is possible for a numbering system to have base properties, but not specifically place value. If that's something that's confusing, think about the Egyptian numbering system. Each symbol increased in value by a power of 10, so it does have a base property. However, we didn't have to put the symbols in any particular order to show their meaning, okay, or their worth. So it did not have place value properties. Again, this is something we think of as interchangeable, however, it is not. Okay, so let's start thinking about our own Hindu-Arabic numbering system. Let's say I have the value 4,325.68. Okay. In terms of thinking about place value, okay, we know that the position of each number here helps us determine its worth. And its worth is determined on a base type scenario. Okay, now what do we mean by that? We talked a little bit about this the other day. If we start counting our place value, this of course is the ones place. Here we have the tens. Here we have the 100s, the 1000s. Okay. Here the tenths, and here the hundredths. Okay. We also took the time to write these values as exponents of 10. Since our place value changes by a factor of 10 every time we change position, we use 10 as our base. So here in the 1000s, that would be equivalent to 10 to the third power. 10 times 10 is 100, times 10 again is 1,000. Of course, 100 would be 10 squared. And here we have tens, which would be 10 to the first power. We also discussed why a lot of times in algebra, sometimes we're told anything to the 0 power is just 1. It's hard for students to realize why that is until they see this pattern. Again, same analogy here with why negative exponents tend to create fractional values or require some adjustment in fractions. That is because we are representing here place value of 1/100th with 10 to the negative 2, place value of tenths with 10 to the negative 1. Okay, now what does that mean? Okay, let's say someone is counting. Of course, they begin counting, let's say for simplicity's sake, in the ones place. We're going to count from 1 all the way up until 9. Once we add an additional 1 to that 9, essentially what happens is we're taking those 10 ones and we're trading them in for a 10. If you were an elementary school student, you might model this by taking 10 smalls and trading them for 1 long. Okay. Every time we accumulate 10 of a particular place value, we're going to trade it up or exchange it up for 1 of a larger place value. The same would happen in reverse if we were going from a larger place value to a smaller. In other words, if I wanted to trade these 5 ones for tenths, I would get 10 tenths for every single one. Okay? It's important to remember that and how that works as we start to be introduced to new bases. Okay? That will be what we start to model and what we begin to show using manipulatives and base blocks when we come to class on Monday.